Question 10, a curve has equation y equals to 1 upon k x to the power half plus x to the power minus half plus 1 upon k squared, where x is greater than 0 and k is a positive constant. In part A, it is given that x equals to 1 upon 4. The gradient of the curve is 3. We have to find the value of k. Now, as the gradient is 3, it means the dy dx is equals to 3. So in the first step, we'll find the dy dx of the curve, and that will be equals to, so 1 upon 2 will multiply by the coefficient, which is 1 upon k. So that will become 1 upon 2k. And x to the power, it will reduce by 1. So that will become minus 1 upon 2. In x to the power minus half will multiply by the coefficient. So that will become 1 minus 1 upon 2, x to the power minus 3 upon 2. And when we differentiate 1 upon k squared, that becomes a 0. So once we have differentiated, now we know that the value of x is 1 upon 4 and the gradient is 3. So we can write this as, okay, so first we can rearrange it and write it as 1 upon, bring it in the denominator and write it as 2k square root of x. And this will become minus 1 upon 2. And now x to the power, so if you bring it in the denominator, that will become x to the power 3 upon 2. Or we can also write it as square root of x whole cubed, as x to the power 1 upon 2. And if you whole cube it, that will become 3 upon 2. So it's up to us how we can write it. So I will write it as square root of x whole cubed. And that is equals to 3. Now substituting x equals to 1 upon 4. So that this will be 3 is equals to 1 upon 2k. And this will be square root of 1 upon 4 minus 1 upon 2 into square root of 1 upon 4 whole cubed. Simplifying this, so this will become 3 is equals to 1 upon 2 k into 1 upon 2 minus, this will become 1 upon 2 into 1 upon 2 whole cube, as square root of 1 upon 4 is 1 upon 2. So this will become 1 upon 2 whole cubed. Now simplifying this, 2 and 2 will cancel. So this will be 3 is equals to 1 upon k minus, and this will become, we can write it separately over here, 2 into 1 upon 8. So this will become 1 divided by 1 upon 4, which will become, we will bring the 4 in the numerator and write it as 3 is equals to 1 upon k minus 4. Taking the 4 on the left hand side, we'll get 3 plus 4 is equals to 1 upon k. And now cross multiplying, so this will be first 7 is equals to 1 upon k. The final value of k will be is equals to 1 upon 7. In part B, it says it is given instead that the integral of one of the equation with the limits k squared and 1 upon k squared, the answer is 13 upon 12. We have to find the value of k. So in the first step, we'll integrate the expression and then substitute the limits. So integrating 1 upon 2 x to the power 1 upon 2. So the power will increase by 1 and that will become x to the power 3 upon 2. And we also divide by the new power. So this will become dividing by the new power, that is 3 upon 2 over here, plus x to the power minus 1 upon 2. So this will increase by 1 and then we'll divide it by the new power, which is 1 upon 2. And integrating 1 upon k squared. So we'll just add an x over here. Now, once we have integrated this, we'll first substitute the limits and subtract them and then put the final answer equals to 13 upon 12. Before we substitute the limits, we can rearrange this to write it as 2 upon 3k, and this is x to the power 3 upon 2, plus 2x to the power 1 upon 2, plus we can write it as x of 1 upon k squared x. So once we have simplified this, now we can apply the upper limit, which is k squared. So now using x equals to k squared, we'll get 2 into k squared to the power 3 upon 2 upon 3k plus 2. So we have k squared and this will be to the power 1 upon 2 plus 1 upon k squared and x value is k squared. Now simplifying this, so the first term, which is k squared to the power 3 upon 2, that will become, so 2 into 3 upon 2, that will become 2k cube. So we'll have 2k cube upon 3k. K squared multiplied by 1 upon 2 will become k, so that will be plus 2k. And over here, k squared will cancel, so we'll have a plus 1. So k and k cube will cancel, so the final expression for this upper limit will be 2k squared upon 3 plus 2k plus 1. And we'll have to subtract this from the lower limit. So the lower limit is 1 upon 4k squared. Now substituting x is equals to 1 upon 4k squared into the equation, we'll get 2 into 1 upon 4k squared to the power 3 upon 2. And we already had 3k in the denominator, plus 2, and x is now 1 upon 4k squared to the power 1 upon 2 plus 1 upon k squared, and now again x value is 1 upon 4k squared. So simplifying this, first of all, so k squared into 3 upon 2 will become k cube. So this will become 2k cube upon 4 to the power 3 upon 2 is 8. 8 times 3 will become a 24. So this will become 24k plus square root of 4 is 2. So that will become 2 upon 2 will cancel out. And this will be k squared into 1 upon 2, which is just k over here. K squared and k squared will cancel out. So that will be equals to plus 1. So we have the value with after substituting the lower limit, and we can simplify to write it as 1 upon 12, and this k will cancel. So 1 upon 12 k squared plus k plus 1, and this is 1 upon 4. So plus 1 upon 4 over here. Now subtracting the two values for the upper limit and the lower limit, and then we can equate it equals to 13 upon 12. So the value with the upper limit was 2k squared upon 3 plus 2k plus 1. And we'll subtract it from k squared upon 12 plus k plus 1 upon 4 and put it equals to 13 upon 12. Okay, so we don't have enough space left over here. So first we can take the LCM on the whole left hand side. So if we take the LCM on the whole left hand side, this denominator is 12. So the LCM will be 12 up here. So we'll have to multiply this by 4. So this will multiply by 4. That will become a 8k squared. This will multiply by 12. So this will become a 24k. This will also multiply by 12. This will become a 12 minus. So in the brackets, we will have. So this will remain as k squared. This will also multiply by 12. So k will multiply by 12. We'll have a plus 12k. And this will multiply by 3. So this will become a plus 3 is equals to 13 upon 12. So this 12 and 12 we can cancel out. Now 8k squared minus k squared will become a 7k squared. So 24k minus 12k over here, as this will become a minus plus minus. So this will become a minus 12k. So that will 24 minus 12 will become a plus 12k. And this is 12 and this is, so this will be 12 minus 3, which is equals to 9. So we'll have my plus 9 is equals to 13. Simplifying this, we'll get 7k squared plus 12k. 9 minus 13 is a minus 4 equals to 0. Factorizing this through middle term breaking, so we can just do the working over here. This will become 7k squared plus 14k minus 2k minus 4 equals to 0. Taking 7k common, so that will become k plus 2. Taking 2 common, that will be equals to k plus 2 equals to 0. Now, as k cannot be a negative value, so k is equals to minus 2 will not be considered, and the other value of k will be equals to 2 upon 7, which will be the final answer for the value of k. So k will have the value 2 upon 7.